Okay, uh, dear students, today in this lecture we are going to describe the phenomena of superconductivity. Our major concern would be uh, to understand this phenomena according to the our examination point of view. You know, our examination will be according to the new scheme developed by new examination scheme developed by IUB, uh, and that is MCQs based. There would be 60 MCQs concerning each subject, and students have to attempt those 60 MCQs according to the time given in the paper. So let's start to discuss the superconductivity. Superconductivity is the phenomena in which it is observed that whenever uh, material's temperature goes down and or after a particular temperature, its resistivity become zero. So this sort of phenomena is called superconductivity. This phenomena was first time uh, observed by Kimberley Fons in 1911. This may be the point for a simplest MCQ that when phenomena of superconductivity first observed, you should keep in mind that it is first observed by Kimberley Fons and in the year of 1911. Uh, and and next point you have to uh, keep in mind that the specimen undergoes a phase transition. Uh, Undergoes a phase transition. Please keep in mind that it is a type of phase transmission. Phase transition. Phase transition mean just you can understand or you can exemplify in your mind as there is a phase transformation from liquid state to gaseous state or from solid state to liquid state. This sort of phenomena are called uh, phase change. But uh, every phase change uh, may be accompanied by certain properties or uh, certain type of uh, changes may takes place, and the specimen or the material uh, or our uh, system uh, uh, exhibit different characteristics on that phase change, and that phase change may be accompanied by certain sort of uh, uh, characteristics. So in that case, we will also discuss what is meant by a first order phase change and second order phase change. Now, because in our context of undergrad examinations, we will follow the text. This text, this text was an introduction to solid state physics by Charles Kittle, and in this chapter of superconductivity, Charles Kittle decided to discuss different aspects of superconductivity under the heading of experimental survey as well as on theoretical survey. So first of all, we are going to see what sort of uh, aspect was discussed regarding the experimental survey. Uh, it is experimentally observed that In superconducting state, the DC electrical conductivity goes to zero. This may be asked as an MCQ in case of a simple MCQ. Uh, what is happening to the what is happening to the resistivity or electrical resistivity of a material in superconducting state? So answer will be it's DC direct DC stands for direct current. DC electric resistivity goes to zero, very close to zero. And the result is that if there is an electric uh, there is an electrical current that flows through that material that or that specimen in superconducting state, that electrical current will persist forever. In principle, you can see that the current will flow without any decline in its value for an infinite time. Uh, in that sense, there was some try to observe through or establish an experiment in which we want to study the attenuation of the current. For that purpose, scientists have established experimental condition for the flow of DC current more than a year, and they observed low attenuation in the flow of current. So after that time period, they actually destroyed the experimental condition by assuming that the current will flow without any attenuation for infinite time. And they actually uh, uh, concluded that the current will flow without any attenuation for infinite time. So next uh, study, next research in this field started, and people want to observe how the supercurrents here mean superconductor here superconductor mean currents mean the current flowing through a material in its superconducting state. So there was two scientists, File and Mills, who try to understand how the decay of current take place or uh, mm, take place in a superconductor. So in that case, they used precision nuclear magnetic resonance methods to measure the magnetic field associated with the superconductor. What does this mean? This means that they established an experiment in which uh, uh, they decided to observe the superconductor through its magnetic effects. That is, they actually measure uh, magnetic field associated with the supercurrent current, and that associated field was observed through the phenomena of magnetic resonance. And after their experiment, they concluded that the decay time of the superconductor is not less than uh, 100,000 years. So this point, as I highlighted, can also be asked as an MCQ that what the observation of Faraday means shows that it shows that the uh, magnetic this they showed that or they concluded that the decay time of superconductor is not less than 100,000 years. Also, uh, decay time uh, can be estimated in some superconducting material, uh, and in that case. The finite decay time also observed. From the above observation, we actually conclude that it seems uh, uh, that the the decay time is infinite, mean the current will persist to flow uh, uh, for indefinite time. But in experiments, if we want to estimate the decay time, then it is also observed that the decay time uh, become finite. And the reason for this finiteness of the decay time uh, for the superconductor is uh, is irreversible redistribution of magnetic flux in the material. Uh, because when current flows through a material, we know that the flow of current always uh, uh, accompanied by the magnetic field, and that magnetic field will redistribute the magnetic flux of the material, and this redistribution of the magnetic flux through the material is irreversible, and this due to this redistribution of magnetic flux, the decay time would become finite. So this was another experimental observation that the decay time is observed to be finite. Uh, so now we stop this streaming.